This is the video for the fourth lab, which is on the pressure measurement. And in this video I will show you the setup and some sample data we got here in the experimentation lab. So I will go over the items in the experimentation. So the first item here, first element, is the pressure transducer. So this is the MEMS type pressure transducer that has a diaphragm inside. And this is the analog gauge. And this is another analog gauge that's very similar to this one, but this is an open one so that you can see the Bourdon tube inside, okay? And we have the cables coming out of the pressure transducer. Remember, one is ground, and we have one cable for excitation voltage. So this is supplying 8 volts to the pressure transducer. And then we have one cable that is for, so this yellow cable, the green cable is carrying the return signal from the pressure transducer. So we are going to excite 8 volts with this cable, use this as a ground, so everything is with reference to this cable. And this is where we read from the pressure transducer, okay? So now these are all connected to the connectivity board, which has the pressure gauge calibration section here, okay? So it has a plus terminal for the driving voltage, which is the excitation voltage, and then a terminal for the ground, a terminal for the return signal from the pressure transducer. And these are connected to the DAQ board here. So analog output goes to the driving power here, and then I read with 2 channels on the DAQ board. So the first channel here reads from the sensor. Okay, so AI0 reads from the sensor, and AI1, which is here, it is reading the excitation voltage. Okay, so this is the setup. So now I'm going to pressurize the tank, and I would like you to see how Bourdon tube is reacting to pressure. So right now we have 0 psi, but remember, 0 psi is not absolute vacuum. That is the gauge pressure. So we have the atmospheric pressure inside. So now we are pressurizing the chamber. See how the Bourdon tube deflected. And also have a look at the needle. It takes time to settle down, so you have to wait until the steady state while performing the calibration, okay? So now what I will do is I will slowly decrease the pressure. I will try to stop at 50 psi, and I would like you to pay attention to the needle. So needle doesn't immediately stop at a location on the dial. So it takes time until it reaches a steady position, okay? So let's decrease down the pressure more. So it's going down to 0. So what you will be doing tomorrow is to basically set pressure at known locations. So for example, now I have around 12 psi inside, and now you will record data for calibration, and then increase pressure by small amounts, by 10 psi. And then record again, and you complete until 100 psi, okay? So that's the calibration. We will talk more about it tomorrow. But now I will show you the final data we got on Excel. So here I have the non-dimensional voltage from the sensor that is corresponding to a pressure of 0 psi, and then we increase the pressure to 20 psi, and then at 20 psi we have more voltage coming out, okay? And as we increase the pressure to 40, now the voltage is even more increased, and then we did it until 100 psi, okay? So now a graph of these pressures is here. So the x-axis here is the non-dimensional voltage from the sensor, so the voltage that we read from the sensor divided by the excitation voltage, and y-axis involves the pressure, and then there is a linear relationship between these two items. So the slope is 161.42 and the intercept is minus 19.472, okay? And then we have a good R-square value here that indicates a good fit to the measurement data, okay? So once you enter this into your program, so this is the Lab4 program, a nice looking Lab4 program. So I have excitation voltage and the slope that I got, and an intercept, and then I have some controls here, and finally I have the calibrated pressure here, okay? So now what I will do is I am going to increase the pressure, and let's see what this is going to read, okay? So I'm going to run the program. So right now it is getting 22 psi, and it is actually what's on the dial, okay? And let's increase the pressure to so right now it's around 45. So with the calibrated pressure sensor I have 45 psi, okay? So what you will do tomorrow is the calibration and verification of the calibration like I did now, okay? So for calibration you will need to obtain the data like I had here for 0 psi, for 20 psi, for 40, 60, 80 and 100, okay? So this is the minimum what you have to do, okay? And then generate the calibration curve, obtain slope and intercept, and enter them in Lab4, okay? So one more time about calibration. Calibration requires known loadings, and the known loadings are going to be known pressures, and you are going to use the analog gauge here to know what pressure is inside the air tank, okay? And then for each known pressure you will use the pressure transducer and record non-dimensional voltage to obtain the calibration curve. More instructions tomorrow. See you tomorrow.